Hi, this is a question from the 2017 exam 2. It is question 7 from the core, recursion and financial model section of the exam. So Alex sold his mechanics business for $360,000 and invested this amount into a perpetuity loan. Perpetuity. The perpetuity earns an interest of 5.2% per annum. Interest is calculated monthly, so I'm just going to underline monthly there. What is the payment? What monthly payment will Alex receive for this investment? So first thing you need to know is what are all the types of loans, and make sure you've got in your bound reference perpetuities, annuities, interest only, reducing balance, all the definitions of those. So a perpetuity is a payment forever loan where you give the bank money and then they give you payments back. So payments can be calculated by your starting value multiplied by the rate as a decimal, so your percentage rate as a decimal. So if we go back to the question, what is the monthly payment will Alex receive for this investment? We can work this out as 5.2% per annum. We need to know what that is per month. So 5.2% over 12 months would equal 0.433 recurring percent per month. So that's very important that we do that calculation first. Then we can turn that into a decimal. If we move the place 2 decimal places back, we can turn this into a decimal, and then we can, from the notes just before, multiply our starting amount by that. So our starting amount was $360,000 multiplied by our percentage per month as a decimal, and this would give us $1,560. So that's what the monthly payment Alex will receive from his investment. Have a look, 1,560. That was 50-50. Students either got it or they didn't. So if we go back to our question, later Alex converts the perpetuity to an annuity investment. So if we go to the notes, an annuity investment is where the bank gives you, where you give the bank money, and then the bank gives you regular payments back. If the annuity is fully paid back, your final value is 0. So the annuity investment earns an interest rate of 3% per annum, compounded monthly. Kind of just underline compound monthly. For the first 4 years, Alex makes a further payment of each month of $500 to the investment. This monthly payment is made immediately after interest is added. After 4 years of regular monthly payments, Alex increases the monthly payment. The new monthly payment will give Alex a balance of $500,000 of his annuity in a further 2 years. What is Alex's new monthly payment? So this is a 2-part question. We've got a first part of our investment, and then after a certain amount of time, the investment has changed. So what we can do is we can get our calculator out and we can use our compounding interest formula and work this out in 2 parts. So we know that from the question it is 3.8% compounding monthly. So we can put these values in here. We know that we're placing in the bank the $360,000, and because it's money out of our pocket, $360,000, we can put that as a negative in there. He also says that he's making immediate payments of $500 there as well. So we can place in another negative because it's money out of our pocket into the investment. So it says for the first 4 years, Alex makes these repayments. So this is our first part. We're working in terms of months. So 4 times 12 is 48, and we are left with one field of information. We can calculate that after 4 years, there is $444,872 and 0.9445 in his investment. So just for memory, I've placed down there on the compound interest underneath our answer from the first part of this question. So what we then need to do is start the second part of the question. So after this 4 years of regular payments, Alex increases his monthly payment. So whenever we have a final value and we change some part of the investment, that will become our new starting value on our next part. But however, the money is in the bank. It's not in our pocket yet, so that becomes a negative. So now we need to change some of these pieces of information in the question. So we're going to do this new monthly payment till we get a balance of $500,000 in the annuity. So we're looking at having a positive $500,000 in the pocket at the end of the investment. We're going to do this for a further 2 years, which is 24 months. And we can then leave this per month compounded and calculate our answer there. So from our answer, it says that it's negative 805.6505059. The negative means that we need to pay that it's money out of the pocket. So that's what the regular payments will be, taking money out of the pocket and putting it into the bank as the investment. So the answer is not a negative value. However, you need to understand what the negative means on that part of the question. So 6505059, that's how much the value is that we invest in. So the correct answer, rounded to the nearest cent, is $805.65. Looking at the assessor's comments, only 26% of the cohort managed to get this question correct, not knowing how to do a two-part question using the calculator, taking the final value and making that your starting value in the next part of the question. Hopefully this helps.